This video is designed to help you understand the way that heat is used in chemistry. And we're also going to be talking about kilojoules in chemistry and how we write equilibria data when we're talking about LeChatelier. So let's start with the sun because that's where all energy starts from. The sun is going to give us both light and heat, and plant chlorophyll uses that light and heat. Plants will grow faster in a hot house than they will out in a cold area. They will also not be able to grow unless they get sunlight. So they need both. Let's go right here. Light and heat are going to do this chlorophyll reaction, which is what we call exothermic. If I can get this to go out, there we go. Endothermic, I'm sorry. Endothermic. Endo meaning that it's taking the energy, the light energy and the heat energy from the sun, and it's putting it into, let's just go back here and tuck that away. It's going to put it into chemical bond energy, which we refer to as kilojoules. That kind of energy. Okay? So kilojoules energy is the kind that we have in the glucose. Now let's tuck that back in, and let's go back down here. You eat the plant and breathe in oxygen. When you do that, you're doing this reaction. You're going to take the glucose, and the glucose has the energy from the sun in chemical bonds that we're going to refer to here as kilojoules, kilojoules of energy. So when we take the kilojoules of energy that's in the glucose and we have an exothermic reaction because we are burning the glucose, that's why we have this oxygen here. This oxygen means we're burning. Okay, that's a combustion reaction. And that combustion reaction is going to produce heat. And that heat energy is what we use in our chemical equations. And by the way, this is what keeps your body at 98.6, plus or minus a few tenths of a degree. So that's the same everybody the world around. Now let's look at the models and see how this might work in an actual reaction. Now this reaction, to tell you the truth, I don't know whether this is exo or endo, but I'm going to treat it as a negative delta kilojoules, okay? Or delta heat, delta H with a negative kilojoules. And because of that, we know that that's going to be an exothermic reaction. That means that heat is going to wind up on the right-hand side. So let's go ahead and put heat over here on the right-hand side, and of course we have to have a plus. So this is how we represent an exothermic reaction. But if you will notice right now, we are not at equilibrium. Because we're not at equilibrium, this thing is going to react in some way or to some degree. So what's going to happen? These guys are going to come together, which reduces the concentration of carbon monoxide as well as chlorine to make the COCl2. Well, when it does that, now we got to think about this guy. We're putting them together, so that's going to be a grouping. When they group, there's going to be some heat. Okay? And that heat, here we go. Let's hold on just a minute. We're going to kind of represent it like this. Because we put two molecules together, we're going to have a unit of heat. How much, how little, that's not important right now, but we get heat. If we put a couple more together, we're going to get more heat. And so we're going to add a little bit more heat. And the heat is being created because when these guys came together, they were like making this, and when they did that, there was heat produced because the delta H is a negative kilojoules. So the heat is on the right. So let's go ahead and put some more together. We're still not at equilibrium, so let's see if maybe one more pair is going to do it. And for some reason, this particular reaction is now at equilibrium. And of course, more heat has been released. So the heat is going to raise the temperature. And so in an equilibrium reaction where we're using LeChatelier, we're taking that as a temperature rise. And now at equilibrium, everything is cool. Now, if I add more heat to this as a stress, okay, I'm adding it from outside now. Here we go. I'm going to add a couple of heats here, maybe 3, and LeChat is going to try to reverse that. Well, how's he going to do that? He's going to take these guys, here, let's group these now, group them because they are together, and here we're going to group them because they are together, and here they're already grouped. So he is going to perhaps move one of these over to the other side by ungrouping them, and when he ungroups them, they come apart, and by doing that, he is also going to use up some of the heat. Well, where does that heat go? It's just out of there. It leaves the system. Go down, get rid of here. All right, and now we are using up heat to make the cobalt, I'm sorry, not cobalt, but carbon monoxide and chlorine. So depending on whether we are moving this direction where we're making heat, or we're going this direction where we're using up heat, okay, the reaction will be shifted by LeChatelier to move things appropriately. Now let's go to an example using the chart. We'll use the same equation here. See, we still got the same equation. And it's still going to be exothermic. So the heat will be a product. And we're going to stress the system now. And in problem 15, we are actually stressing it with 2 stresses. We're going to have a temp stress and we're going to have a pressure. So we're going to see what each of those will do because they work very, very differently. So let's do the heat. The stress is the temperature goes up. LeChat wants to make the pressure go down. And to do that, he's got to remove heat. To remove heat, he's got to go to the side that is opposite and opposite from the side that the heat is on. Well, which side is the heat on? We can see it's on the right. So opposite is going to mean a left shift. Okay, so we know what the temperature rise is going to do. It's going to make LeChatelier want to move to the left. But now let's look at the pressure. Well, pressure, we've got to know moles. And so we're going to add up the moles on the left side first. And because we look at this guy right here, and he has no coefficient, that means it's a 1. And we're going to add that to this guy's coefficient, which is also a 1. And so we have 2 moles on the left. And because this guy only has 1, we're going to have 1 mole on the left. And you say, well, gosh, well, what about the heat? Well, the heat is a problem in terms of moles, but it has no coefficient. It's not really a product, but it acts like a product so far as the equilibrium shifts when we're talking about anything like this first example with temperature. Then we use it as a product or a reactant, depending on whether it's exo like this guy or whether it's endo, in which case this guy would be over here. So for this reaction, we are clearly exo because the delta H is minus 220 Kelvin, 220 kilojoules. That's what this means, kilojoules. And so now we got to deal with pressure. Pressure goes up. LeChat wants it down. He's going to make it go down, or try to make it go down. He can't make it go down all the way to where it was, but he wants to move it down to the side by going to the side with fewer moles. Well, the side with fewer moles is wants to go to the side with fewer moles because he's trying to reduce the pressure, that's going to be a right shift. Now, you're not experienced with this yet, but when you have a shift, if you have two different shifts, and one indicates that LeChat moves to the left and the other indicates that he moves to the right, the net result is you cannot predict what's going to happen because these guys are all relative and you don't have exact numbers. So to be able to answer this problem, you simply say because there's a left shift for the temperature change and a right shift for the pressure change, there will be no change. And that's how you deal with LeChat. If we dealt with these guys individually, where we were dealing with temperature only, it's very clear a right shift. If we were dealing with a pressure change only, it would be very clear as a right shift. So that's how these guys work. I hope this helps you in understanding the difference between temperature and pressure changes, and you can do your problems in regards to heat.